Hey guys, so this is post commentary. Before we get the video started, I do need to make note of a critical error that I made. So on screen now, you're seeing the three blocks. I have arm pickup, then I have that going to a 5 megahertz bandpass filter. That is incorrect. The arm pickup for the video goes straight to the NLAC circuit, which I'll talk about in a bit. And then after the NLAC, it then goes through the bandpass filter, and then video modulator, and then it's the same from there. So just a quick note: when you see arm pickup, then 5 megahertz bandpass filter, then NLAC, switch the order of NLAC and 5 megahertz bandpass filter, and that's much more correct sequence for video processing on the CED players. All right, on to the video. So before we continue with the repair, or rather start, depending on when I decide to put this in the video, first I feel it appropriate to actually go over like the just give a block diagram of the circuitry for a typical CED player. For the means of this repair, I'll just be going over the video operation, because that one's more complex, because audio it really at least for our mono players, it really is just demodulate, and then it's pretty much spit out to the RF modulator. So nothing of that interest there. But for video circuitry, it might be worth giving an better explanation. So I already wrote down where we start from. Of course, we actually need to pick up the signals off the disc, which is the purpose of the arm circuitry. In the stylus arm, there's your resonator, which is that's like, I can't really explain because I still don't fully understand it, but that is actually what gets the signals off the disc. And there's also, and after the resonator, it's sent to the preamp. If you looked at a CED like stylus arm before, like on instance on your JK players, there's that little board on the side. Well, that's the arm preamp. The purpose of the preamp is to, amplify the signal so that they're at appropriate voltage to actually drive the signal processing circuitry that's in the player. Off the disc, goodness, of course now I can't think of the actual number, but essentially the arm pickup should be about like 0.4 volts peak to peak, like 0.2 to 0.4 volts peak to peak, like in that range. If it's like any lower than that, or if there's like no signal on it at all, then that would mean a bad arm, and you have to look there. But after the arm, it goes through, on the mono player like the Toshiba here, it'll go through two bandpass filters. This bandpass filter, 5 megahertz, allows the frequencies of the modulated video signal to pass through. 716 kilohertz, that's the frequency of the modulated left audio channel. On CED, how the audio is, I might as well just talk about it. All discs have the 716 kilohertz modulated signal. That is that's what the left channel is modulated at. The left, I keep saying left channel because on your stereo discs, the left channel is still modulated at this, but the right channel, I will just say, is modulated at 905 kilohertz, and that goes through its own bandpass filter and it's demodulated as such. And on stereo players, there's an additional like circuitry that I can't explain because I still don't necessarily fully understand that, but like if you see L plus R, L minus R, that's what I'm trying to get at. That's if it's a stereo disc, it'll go through that. But we were just talking about mono disc, and mono discs have the one audio carrier, which is this, which is also the left channel on your stereo player. So if I were to play a stereo disc in my Toshiba here, I'm only going to get the left channel audio. The right channel audio is not going to get picked up. So that's just audio. But now comes back to the video. So after we go through this 5 megahertz bandpass filter, we go through a circuit called, I call it NLAC. I'm sure that is how it's pronounced, but knowing me, I could be getting that wrong. The NLAC purpose of this is to remove sound beats from the picture. Basically, if it weren't for this, there just because of pickup, I believe that's the reason. There would be like a 716 kilohertz sound beat in the picture. So what this does, I believe this also actually relies on the feedback from the next stage, the video demodulator. But what that does, it just removes the sound beat from the final picture, so you get a clean picture. That's it for that. I'm not going to be here arrows to indicate. I won't be going then into full detail. Well, mainly because I can't remember the precise explanations for each, like component in there, but again, block diagram, you just need to know like basic operation. Video demodulator, I mean, it is kind of self-explanatory, but but that does help, well, not help, that demodulates the big signal that was picked up off the disc. So now the next part gets a bit interesting. We come to the comb filter and also the defect corrector. So the comb filter, that should sound familiar if you've dabbled in electronics, more specifically the old AV gear. Just how the composite video is put on the disc. Again, I'm blanking on the exact term or reason, but the chroma. Shoot, I should write that down, because I'm going to be saying that a lot. Chroma is the color signal. Luminance is the black and white signal, or brightness is how composite video works. Those two. Anyway. But just how the color signal is put on the disc, it is necessary to separate them. So the comb filter, it separates it through through exploiting how like luminance and chroma signals like work. There's a 1 horizontal line delay and that's part of how that works, like using that and also adding it back. So the luminance, that's, if you, I believe for a delayed horizontal line, the luminance doesn't really change. So when you add the delayed like video signal back, the lumens will be in phase, but the chromas will be out of phase, and so the chromas cancel, and you're left with what's called a combed luminance. And then chroma actually is set through the signal is delayed, but it's sent through an inverting amplifier. So now the luminance is going to be out of phase, but the chroma is going to be in phase. I believe that is the correct explanation. And you're left with what's called the combed luminance. I'm sorry, combed chroma. I totally forgot what I was talking about. So I should kind of go over that. So defect corrector. If that actually also relies on this in the demodulator section, if it has a way to detect like a defect in the picture. Now that doesn't mean, oh, it's a crappy picture. It just means like a horizontal line was lost in picking up the signal. So to make it not obvious that it did that in the final picture, a signal is sent from here to the defect corrector. The defect corrector substitutes the defected line with the previous horizontal line, and on composite video, it's pretty much like you won't notice that happening. You'll notice it happening, I believe, when it gets like 3 horizontal lines need to be substituted. I believe that's when it becomes obvious, but let me just write that down. So defect corrector. Oh, how do I write this down? If demod detects defect, substitute. So after that, we right after the comb filter, so now we have our combed chroma and combed luminance. I should also make note the combed chroma is the final for an NTSC signal. The chroma is at around 3.58 megahertz, but for well, in this case, it's, I want to say it's here. It's so, and later I'll explain. Later I'll go over how, if that truck would mind its business. But hold on, let me just make sure my numbers are correct. Okay, so I was right on that frequency. It is 1.53 megahertz. So after, well, technically it's still in that section of the circuitry, but next we go to the vertical detail out and the DAXI part of the comb filter. This just the DAXI, first of all, on CED is it gives the field number, so then the player can convert that to minutes if it has the LED display, or minutes and seconds if it's 400 model. DAXI, it also tells the player what kind of disc, so if it's mono, that'll be in the DAXI. If it's stereo, that'll be in DAXI. If it's dual audio, the DAXI will also tell that. On a mono player, those bits of information are not necessary because, well, it's only going to play back the left channel audio anyway. And this is where also the band numbers are. So again, your 400 model player, this is how it's told, like what bands are what if you're playing back like one of the interactive titles, or like one of those music titles where the songs are chapter marked or banded. So, but this is contained in the chroma, so it has to go through. So, the circuitry since applies the low pass filter to the combed chroma. So then all that information will get extracted out, and basically the actual color signal itself is going to be left intact. So next we go to the kind of final stage here, video converter, and the hole punch is gonna mess with me, but I should just time-based corrector. There we go. So, as I was saying, for NTSC, the color signal is at a frequency of 3.58, but our color signal just taken off the disc is 1.53 megahertz. So how do we? So yeah, you are going to have to convert the frequency in order to get the proper NTSC color signal. Well, fortunately, that's done in the video converter. So, VC. Again, there's not really a need to actually explain what happens, how it does this. And of course, in order to get an actual composite video, we need to bring back the chroma and the luminance. To get composite video. So that's how the video converter part works. Its job is just to get the chroma to the standard 3.58 megahertz, and at the end it combines the lumens and the chroma, and that's output at a pin 2 of that big video converter IC. So I ran out of room here, but I'll just use this unused space to quickly explain the time-based corrector. So, you gonna focus? There we go. So, time-based corrector, what's that? So, obviously not every CED is on the microscopic scale is made exactly the same. Eccentricity on each disc can vary. The hole may not be punched to the exact, like, you know, point. So, basically, it's not going to be like extremely perfect, you know, when you're trying to play back these this using the stylus. So, but if we just left it as is, there would be, you know, frequency deviations in both the luminous and chroma. If you've seen the horizontal jitter on some players, well, that means something's faulty with the time-based corrector circuitry. Whether the coil itself, which I'll talk in like a minute about, or the or like any electrical variations that aren't just physical. If those are left, if those are just left as is, then you get that jitter. You get color variations too, assuming your turntable platter is nice and, you know, lubed. So, should I write this down? Oh, I didn't even explain what the hell it does. So, I'd mentioned the coil. The coil, the arm stretcher coil, that. Well, shoot, how do I go? What should I explain first? I guess. All right, I guess I'll explain it this way. So. So the video converter IC outputs an error signal. Oh, wait. No, I'm sorry. So, in the video converter circuitry, there is a 3.58 megahertz crystal. To a reference. So embarrassing. I spelled how do you spell crystal wrong? There we go. Okay. Crystal. We on the same page? That's how you spell the word crystal. Oh my god. Anyway, compares chroma to a reference. Basically, after comparing this, it does some IC does some neat stuff, and then it makes an error signal. I don't think there was a need for quotes there, but I'm just going to leave it because I wrote this in pen. And this signal is then sent to the circuitry that controls the arm stretcher. There we go. Circuitry. I say circuitry because there's, of course, it's a coil, and we want to, you know, make it move back and forth. So there's a actually, if you've seen the video of John working on that JC Penny player that Josh had, the arm stretcher, that chip there is actually a chip that's used throughout the players, which is a quad op amp. And even though the arm stretcher circuit just makes use of 3 of them, it's still a quad op amp. So it's of course, for this, I would refer you to John Lenks. I believe that's his last name. his book on this, but because he can totally explain this way better than I currently am trying to attempt to explain this, but he gives a detailed like operation of how that works with the op amps. So anyway, I say it's a circuit because it pretty much, well, is. And it goes back the error signal depending on like the phase of the signal. It goes back to the IC, which can then eternally correct for any of those electrical variations. So without the time-based corrector, you would have a very jittery picture and worst case variations in the chroma. So that part's contained in the video converter. So anyway, so the final output of the video converter is pin 2 of the video converter IC. That is the final composite video that is then sent to the RF modulator and to the video out. If you have a player that has the RCA jacks for output, and that's the video part of a CED player. I could have explained this a bit better, but I felt the most important part is to at least tell you the absolute basic functions of each of these, so that when you have to do electronic troubleshooting on these players, you can at least have a bit of a grasp on like what the inputs and the outputs of the section is, because as we'll see in the Toshiba here, if you have a certain signal missing as an output, well, then that's going to tell you that what's a good, wait, can I try and get this all in? I think this is as good as it's going to get. Sorry about that. But if you have if you have a good input but a bad output, then, well, then it's safe to say the trouble's in that section. And just knowing just what, signal you're trying to look for can make, all the difference in the world. So I hope I explained this sufficiently. I feel I could have done better, but if I try this again, I'm just going to end up doing this like 15 times, trying to make it as perfect as possible. So I have to know when, so that I have to like stop the buck here, basically. I hope that sheds some light how video at least is done on the Select Division video disc. And next time we'll take a look at the Toshiba. All right, take care.